Okay, so in class we talked about how Chebyshev had his different percentages. So 68% for one standard deviation, and we can split that in half. And then this next one was 95. So again, we subtracted and got, what, 13.5% for each little area there. And then he, within 3 standard deviations, was 99.7. So we subtracted and got, what, 4.7 divided by 2 is what, 2.35%. And these little wings. And then the 100% is the entire chart. And this does go off to infinity. So, but again, in theory, it's 100%, even though it does go off to infinity. So the little wings are 0.3% and split in half, so 0.15%. And so, for example, if your numbers are nice, life is great. So say I want to find the probability or the percent of people that have IQs between, say, 85 and up to 115. Well, if you notice, if I add that, that's 1 standard deviation, that's 115. If I subtract 15, that's 85. So it just works out beautifully that it's, you know, positive 1 standard deviation, negative 1. So I know that's 68% of people. The problem is things don't always land nicely, and so then we need to do something a little bit different. And so what we do is we use a z-score, and what the z-score does is it tells us kind of where we are at on the normal distribution. And instead of labeling it with like specific numbers, like here's a mean, which is 100, and then add 115, 130, and then 145, and then subtract it 3 times over here, every time we do new data, this changes. So if I'm dealing with, say, an exam where the average is 80 and the standard deviation is 2, then I would need to redo all my numbers. And then if I'm dealing with ACT scores, where maybe the average is 22 and the standard deviation is, say, 4, and I add it over and over again, I'd have to change. Or if it's somebody's height and the average height is, and you can see where this is going. It's going to keep going forever. So instead, what we do is we're like, fine, let's let 0 be the mean, and we'll just do 1, 2, 3 for 1 standard deviation, 2, 3, -1, -2, -3. And these are z-scores, and z-scores do not have a unit. So where standard deviations might be points or percentages or inches, these guys are just a z-score of 1, which really means 1 standard deviation. So here's your formula. So you take your data compared to the average always, and you always divide by the standard deviation. So you're always looking at you first, and how do you compare to average, because that's what people do. And then we divide by standard deviation to see if it's a big deal or not a big deal. All right, so say I want to know that the probability of someone that has an IQ is less than, let's say, 120. Okay, 120. So the score is 120. That's what I care about. That's my data. Comparing to the average. And notice these have units, points and points. So this person is actually 20 points above normal. But again, is that a big deal or not a big deal? Now I could label this as here's your mean, here's 115, here's 130. So I could kind of just eyeball it and say, well, you know, 120, you know, it's within 2 standard deviations, probably not that big a deal. But I want an exact probability or a percent. So what I do is I divide by the standard deviation to kind of see how big that really is. Now again, this has a unit of points also. So notice what happens. Do you see how there's no unit anymore? They cancel. So let's see if I reduce this or divide on a calculator. Let's see. I don't have a calculator handy at the moment. I probably should. Divide by 5 is what, 4? So what is that? 1.33 repeating. All right. So now that's 1.33 basically standard deviations above. Now, there is a handy-duty chart, and I'm going to minimize this for a second. And so here's a handy-duty chart, and unfortunately it's on the negative, so everyone see those are negatives right there. I don't want that. So let me see, and of course, there's a positive. All right, and if you look at the chart, notice that it only goes to the left. All right, and so that's important because it will only give you probability to the left. So I'm going to look at 1.3, which is here, and where it intersects with 0.33. So 1.3 with an extra 3 is going to the left is what? 90.82%. So positive 1.33 is 90.82. So I'm going to minimize that and get back to my other screen. Come on, maybe. All right. So I want to know the probability that is, less than that. And it goes everybody that's less. So, someone that is 100, someone then that's 110, anything like that. So again, what was my percent again? 1.33 was what? 90.82. So 90.82% of people are going to have an IQ of basically at a cutoff of 120. So 120 or less, which makes sense. This is half your people. And then you have what? The other 34%. So there's 50 and 34. So that gives you what? 84. And then you have a little bit more in here. So, that seems logical. All right. So that's how you would do it if it goes to the left. And you obviously need to use the chart to figure it out. All right. What about if it goes to the right? All right. So say someone has a probability. And I want to know the IQ is higher than, say, 140. Okay, so how rare is that? Well, again, I could write my numbers on here. So here's 100, 115, 130. So, that's 145. That's looking pretty rare, right? To be in that tiny area. All right, but again, we don't know that exact percent because it's not landing on a nice little end to our Chebyshev's rule. So we are going to take our data and get a z-score. So we're going to take our data, which is what we care about, compare it to the mean, and divide by the standard deviation to see if it's a big deal or not. So my data is a 140. The mean is 100. So this person or people group are 40 points above normal if they're up here. Now, is that a big deal or not? Well, what's my standard deviation? So if I go back and look, my standard deviation is 15. And again, those have units, points. But z-scores don't have points. There are no units on these. Now I'm going to, again, divide by 5 is what? 8. Divide by 5 is 3. So that goes in there, what? 2.6 repeating. And again, you can use a calculator. I just didn't grab one. So luckily, my numbers so far are turning out okay. So 2.67. Now notice this is going to the right. Okay. But that's kind of a problem because the chart only goes to the left. So let's look up, and this is positive again. So let's look at positive, where am I at here? 2.67. So on my chart, sorry about that. There's the negative side. Okay. So 2.6 is here, and down too far. 7 is over here. So 7, 2.67 looks like what? 99.62. All right. So what that means is this is 99.62 because the chart always goes to the left. The problem is I want this guy. Well, again, if you have, say, a $100 budget and you have spent $99.62, how do you get what's left in your budget? Well, you just subtract them, right? So we know all of this is 100%, and we can subtract. So the probability of us landing in that area right there is what? 0.38%. Okay. Not very likely, right? So again, people that have an IQ of 140, higher than 140, is going to be actually quite rare. Okay, and there's a special club for that, and I can't remember the cutoff, but Mensa is a club for people with high IQs, and I'm not exactly sure what the cutoff has to be for that, but I guess if you have a high IQ, you can apply to join. All right, and then the last type is when it's trapped. Okay, so I'm just going to erase a little bit here, and we will do one where it is trapped between two numbers. All right, so say, again, and it's always a good idea to draw a picture. Even statisticians at Iowa State draw pictures, and they're way smarter than I am. So here's 0, 1, 2, 3 standard deviations. 1, 2, 3 standard deviations. And again, tails are rare. All right, so say I want to know the probability that someone has an IQ say between, let's do 90 and say 110. And so we know that, again, if I added it, if this was labeled 100 for the mean and this was 115, subtracted it, this is what, 85. So 90 is over here somewhere, and 110's over here, and so I'm somewhere in there. So I do know one thing. I do know it's less than 68%, because 68% would be one standard deviation below and one above, and I know it's less than that. But it is, you know, kind of in the middle there, so I don't know, should be fairly substantial. So since I have two data values, that means you are going to do two z-scores. So you're going to take your data compared to the average. And again, this one is 10 points below, and that negative matters. And then you're going to divide by the standard deviation to see if it's a big deal. And again, you can just divide on a calculator. I just don't want to dig mine out. So what? Divide by 5. Divide by 5. So what is that? Negative 0.67. All right. And then I'm going to do another z-score for the high end. Okay. So that's the z-score for this guy. Now I need the z-score for that guy. So that was what? 110. So this one is actually what? 10 points above. So positive. Divided by, let's see, what was that? Did I lose? Yeah, somehow that didn't get written. Divide by 15 points. Again, units are canceling, so that's why z-scores don't have units. And this one actually equals 2/3 as well, but it's positive, so 0.67. All right, so again, if these numbers weren't here, right, which typically we don't always write those, the mean would be in the middle, which is at 0, and we would have a z-score of 0.67 and another z-score of negative 0.67. And I'm going to use my chart to find the probability. Now, before we go there, and I need to erase a little bit more, we need to think about how we're going to actually get this. All right, so, if we think of a rectangle, and say that I tell you the area over here of the area, let's see, say the total area is 100, say, square feet, and you know this area to the left is, I don't know, maybe 25 square feet. Okay, this area right in there, you know that. And then someone else tells you that the area of all of this, right here, not including that, but all of this together, so if you put these together, that the area of that is maybe 70 square feet. And you're thinking to yourself, yeah, but you know what? I just want the area of this middle part. I don't want that other part. Well, if you look at that then, how would you get that number? Well, all of it's 70 for these two parts. You don't want the 25. That's not what you want. So you could just subtract these two numbers. So if you take 70 minus 25, that 45 square feet would be what's in there. Okay, and then obviously we could figure that out if we want to, but we only want the middle. So we're going to use that same idea with our chart to get the probability that we want here. So we're going to look at the probability of, oops, I need to be able to draw here. All right, and yeah, that's pretty sad, but all right, let's try again. So here's the normal distribution. All right, and so we have what? Negative 0.67 and positive 0.67. All right, so we're going to use our chart, and again, remember the chart always goes to the left. That's the problem. So I'm going to look at the negative 0.67. So I need the negative, and line it all up here if I can do this. All right, so I have a negative, we're at 0.6, and where's my 7? Right there. So negative, so what is that? 25.14. So 25.14% are again this direction because it goes to the left. It's going to the left. Now let me look at the positive 0.67. So positive 0.67. So if you look there, is 74.86. no, let me 70.